So in trying to continue to kind of evolve the neural net concept, one of the issues or problem that comes up is, we have the Henneman size principle, right? Which essentially says that there's a linear recruitment in motor neuron pools, right? Whereby like if you have resistance where the load is essentially light and then it goes from light to heavy and then eventually to maximal. What's going to happen is you're going to get sub-maximal recruitment or suboptimal recruitment. This is an idea that essentially Zatsiorsky writes about in the Science and Practice of Strength Training.
Hmm.
And there's like there's a legit image in the book, and it shows what happens when a non-maximal weight is used. And the context as to why they're describing that is so that people start to use maximal loads because a maximal load is going to stimulate the entire motor neuron pool, whereas a load that is submaximal isn't going to recruit that motor neuron pool. In the context, another layer of context is they're saying that, listen, if a motor neuron hasn't been stimulated and recruited, then it hasn't been trained. And so what ends up happening is the discussion that we're essentially at. So this is going to be kind of more of like an open brainstorming session, I suppose, is when we essentially develop this neural network of absolute strength, right? You start to figure out that, hey, like that linear recruitment isn't going to work in a nonlinear system.
Yes.
Is there anything that you
Yeah.
want to say specifically? So essentially what we're saying is we're kind of at a point in time where the Henneman size principle is starting to now uh, uh, have other logic that's kind of eroding its and this
Yeah, I think it's yeah, I think I know we've kind of had these discussions in the past, and so I don't remember exactly how it came about or what we said, but the size principle is kind of along the same lines as the A.V. Hill, sarcomere mechanics and all this stuff. It's great. It forms a foundation of our understanding of muscle mechanics and muscle recruitment and muscle recruitment under progressive loads and so on and so forth. But now that we kind of have a better idea of the integration of you know all systems within the system and the fact that all the integration is nonlinear, it seems to now be that the Henneman size principle doesn't seem to make an accurate understanding of how motor unit recruitment occurs. Um, so again, I think that when you think about the principle itself and kind of going from progressively smaller to larger units, and you kind of correlate that to our concept of the neurological network. The neurological network is really, as is the nervous system in this analogy, it's really just a bunch of nodes, and so it doesn't really matter the size of the node per se. You know what I'm saying? So I think maybe we should kind of just brainstorm like piece by piece as we kind of go through this. And obviously, from a physiological perspective, smaller to medium to larger motor units kind of makes sense from an explanatory perspective. But when you think about the network concept, like the nervous system in the case of muscle contraction and muscle output, it's designed just to create an output, and the output has to match the level of demand, let's say. Does that make sense? So
Mhm.
like whatever is whatever the stimulus is that the nervous system has to respond to is ultimately the level of output that the nervous system has to give,
Hmm.
right? And so so when you think about it from a network concept, really what you're, and we've obviously written about that, we've spoken about that, and we're continuing to try to hash this whole concept out, and add to it, and try to make it more digestible for people, but also we're trying to understand more as well. And so when you think about it from a network perspective, networks are just a bunch of nodes. And so it doesn't really matter the size of the node per se, because from a network perspective, you have layers of nodes. And we've written about that. There's the outer layer, the hidden layer, and then the inner layer of the network, or the output layer. And so when you think about it from a stimulus response perspective, it's just a matter of what are the connections that are being made within the network to ultimately create the output to respond to the stimulus,
Hmm.
right? And networks don't function linearly. And I think
Hmm.
that's an important distinction. So